Hi, welcome to this new tutorial. As you may already know, they are redesigning geometry nodes. It's not like starting everything from zero because we are using the same spreadsheet, the same concept, and some nodes are the same, but we are using less attributes, and I will show you a bit how that works. So I created this tutorial series, and we are going to see how we can create this cupcake here. We have control over the surface of the top. We can also control the amount of waves we have here on the paper. We have the base. We can change how small that base becomes. The radius of the entire cupcake. We have a cream. We can control the thickness of this cream, the height. We can also control that tip. And we also have chips. We can also duplicate them, and they get complete different colors. So we are going to learn how to do this with nodes. So if you're interested, let's get started. Okay, so this is not yet in master, so what we have to do is to download. If you want to follow along, you go to download Blender, then you go to experimental. Here you have the experimental tab, and here we will search for geometry nodes fields prototype, and you can install this branch on a separate folder and use it from there, so you don't have to mess with your current installation. Okay, when we open the new Blender branch, we go to the geometry nodes tab here. We still have our spreadsheet on the left here. It's the same as it was before, and it shows the information of the object we are working on. In this case, we are going to select this cube. We can use any object here. It's more like a placeholder, the object that will contain the geometry node setup. And in this case, what we are going to use here, instead of a cube, we will delete this, and we will use a rounded cube, and we will change this to a radius of 1. This way we have like a sphere. If for some reason you don't have the round cube on the menu, you have to go to Preferences, Add-ons, search for Extra Objects, and activate that. And then you will have more options when you add mesh, all the ones on the bottom. And we are using this round cube because it's what I'm going to use to create the dough later, so it will be handy to have it already on our setup. So we create a new geometry nodes here, and as usual we still have the same as before. If we disconnect this, we see nothing. If we add here like a cube, and we connect this to the output, we see this content. So whatever we plug on the output is still the same. Whatever we have connected to the output will be the information we see on the spreadsheet. Let's connect something simpler to see it more clear. We use a cube, and we see the 8 vertices that are part of this cube, and you can see the location of each of those vertices on the 3 axes, X, Y, and Z. On the new version, we have an index that it's working now. We have access to these numbers with a node called index. That's super handy. And this is the number that we have here. And with this, we can, for example, select a specific vertex or face with the number. I will show you, for example, a little example here. we will use a math node set to compare, and I will compare my index with a number, in this case 1, and I will leave the tolerance here to 0, so I don't get any other number, just the 1. Because if we, for example, set this to 0.5, numbers that are 0.5 lower or higher than 1 will also be included in the mask. And the output will be, if this is true, it will output 1, and else it will output black or 0. So in this case, we get a mask that will only include the 1 on the index. We add a point translate node. And now this is new. We have a selection input here that we can plug a mask onto it. We will connect this to our line. We will change this value to 0.5 on the z-axis positive. So everything moves up. But now, if we plug the selection, you will see that only the vertex with the index number 1 will be moved. And if we change the numbers here, you will see how now the number 2 and 3 and so on. At this point, we cannot see these numbers, but we will eventually be able to do it because, for example, Houdini uses this and it's already in Blender. If you have developer extras activated and you go to the overlay menu, you will see indices here. And now you can see the number of each of the vertices. So let's test this. Let's connect our geometry, original geometry here. So we have our numbers and we will select a vertex here. I will select this one and you can see that only the vertex 97 it's moving up. So we could use this eventually to extrude specific faces, or I don't know, it will be way more easy to create complex shapes. We will use a circle mesh and we will use an extrude. This is something new and I will show you a bit how it works because it's also interesting. Combined with the index, it may be of a lot of use. So if we plug a cube, for example, here, we can use this to, for example, extrude the faces of this cube. If we do it like this, they will all do it at the same time. But if we click here, we can extrude them individually. And we also have the option of making an inset, so the faces become smaller. And we have two outputs here. Top face is the face we are extruding, and side faces are the ones that are created on the sides of each of the extrusions. And what we can do with this, for example, if we create another extrusion, we can use one of these selections to determine which faces will get extruded. In this case, I'm using only the face, the top face. And now let's say we want to, for example, extrude the sides of this new extrusion. So we can duplicate this again. We select the sides. And now we have extrusion of those faces to the sides. We could create, of course, more specific selections with numbers or index or masks in different locations and create more complex shapes. But as you can see, it's already something interesting. Well, let's remove this and go back to our cupcake. So extrude. So let's plug this here and this to the output. And you will see that we have a circle now. We did this way because we wanted to cap this circle. So I'm going to use an n-gon. That's all we need for now. In this case, I want this to be the floor of the paper, or so I won't go up. I will do it in -1, and this will be the bottom of the paper. An effect of this is that this will have inverted normals, and we will see how we can fix this. Eventually, there will be a node to invert them, but we don't have that now, so we will manage with what we have. Okay, the next step, what we want to do is to have that like wavy pattern or shape of the paper. That we need to find a way to select 1/2 vertices along the circumference of this shape. Since we still can't see the index of these vertices, what we can know is that if we alternate our index 1 by 1, like the first will be 0, the second will be 1, the third will be 0 again, we will get an alternate selection. For this, we also need an even number of vertices here, so I will limit our vertices to an even number. So we will start by exposing the radius. This will be the radius of the paper, and also for the entire cupcake. We will leave it at 1 for now. And we will also expose the number of vertices for our paper here. We can change with N. We access this panel and we go to group. And we can change the name here. You can use the name you want. I'm not sure how this is called, so be creative. Now we need to create our alternate selection and also move those vertices a bit to the center. So how we are going to do this? We will make use of some new nodes that we already saw. Index, for example. We will use index in this case. So here we have the index of all of our geometry here. And the way this works is, depending on where I plug this, it will be the corresponding index to that moment or that situation of our mesh. If we make changes later and we plug it after that, the index will be different. So it's important because it's related to the moment or place where you plug it. We will also use position. It works the same way. It's based on the object origin, and it has the position of the vertices based on the object origin. We still have our original position attribute and we can use it. We also have a node called store persistent attribute that we can use to save a state of an attribute for using later in the setup. We'll use a set position node here, and everything will go to 0 because that's the position we have here. So how can we make the alternation? We will use the index here with a math node. We will set it to ping pong, and this will make it go. We will set this to 1, for example, and it will go from 0 to 1. Then it will be reversed and will go to 0, and it will reverse again and go to 1. So we will have an alternate 0 to 1 value for all our index. And that's exactly the mask we wanted. How can we see the content of this value here? I found a way to do this, and we have to add the node that I was talking about, the store persistent attribute. And we can use this. We will plug this on our line. We will name this attribute whatever we want. It's not important, it's just to find it. So now you can see the content of this attribute, and if we plug this here, we can use the there's float, vectors, whatever you want. And so we plug our content here. I will set this to 1. That's what we originally wanted. And we plug this, and we can see that the value of this input, it's 1 0 1 0 1 0, and that's the alternate mask we wanted. So we can remove this. It's only to check that everything was working. We plug this here on the selection, and we have selected 1 every 2 vertices. For now, if we connect this here, the selection would go to the center, because that's the information we are putting on this position here. This position is the actual position of the vertices before we make this transformation. So if we plug this here, they will go back to where they were. We have our selection. So if we now use a vector math here, and we multiply this, I will multiply the z-axis to 1 because I don't want movement on the z-axis, and we will use a combine to be able to access the 3 different axes independently. I will set it to 1 as it was. Now we can use a value node here to be able to drive X and Y at the same time. And since we have our radius of 1 meter here, if we multiply this by, for example, 0.92, it will be 92% of that diameter or radius, sorry. So now we can control this shape, this star shape here. If you want, you can expose that value also. And now we have to set, this is what I was talking about, because we need even numbers, or we will end up with something like this. So we are going to use a math node here. Since this is integers, we don't have to worry about the fractions. We will use this maybe as a limit. We will use snap. Yeah, there we go. And we will snap. This will only let values of whatever we put here make changes only every, for example, 2 in our case. So this will only change when we have changes in the value of 2. Now, if we change our value here, it will only change every 2 units, so we won't have any more problems. And we have to also limit this, because if you go too low, it will I don't know, destroy itself. So we will use maybe 30 here as our minimum, and I don't know, maybe 70 as a maximum. If you want to fix those numbers, you can multiply the input by 10 or whatever, but we are not going to lose time with that. So now we are going to fix these normals that we need to. If you don't know this, here you can activate the face orientation to see the normals, and we are going to invert them using a transform node here. And all we have to do is to change this to -1. So it's basically like mirroring the object on the x-axis, and the normals will get inverted. Eventually we will get the node to do it. Now, to be able to control the base, the size of our base here, we will do something similar to what we did for the wavy shape. If you remember, with the extrude, The top face is the face that we extruded, and that's the floor of our paper here. So that's exactly what we need to select for our transformation. We will use a set position node here. We will use this selection here. We will plug it here, and it will obviously go to 0 because we didn't calculate this yet. So now we will do something similar to what we did before. We will be using the location. We could use the same as before, but just to have it closer, I will do it like this. And we will use a vector math. We can duplicate this. And we will multiply this by, again, the C. We don't want to move on that axis, so it will be 1. We will use another combine here. And this, I want to expose this because I want to have control outside of the base. So I will expose the X value here. And we will plug the same value to our Y. That way they have the same value, it's still round. And with this value now we can control how much of that radius or diameter we get for the base. So 0.5 will be half of the size. In this case it's at 0. We have to change the name, and we change the limits from 0 to 1. It's fine. That will give us the range from the center of the 0, and at 1 it will be the same as the top. So now we can select everything here, press Ctrl J and rename this. So we know this is the notes for the paper, since we are going to add a few more things. The other thing we need to do is to assign a material. We will use this node here, and we will create a simple material for this. We will go to the shading tab. We can add a new material. We'll just create something simple and go back to our geometry nodes. We can select this so we can see it. And now we can actually see what is going on. If you want this to change based on the instances when we duplicate this object, we can use the object info node, the random, with a ramp set to constant, and we use this value. It's a 0 to 1 value based on the instance. So it will take one of the colors of this ramp, depending on the number. If we duplicate, you can see the different instances get different colors because they have different numbers from 0 to 1. Remember to save your file, and on the next part we will continue with another part of the cupcake. Thanks for watching, and see you on the next video. If you want to support this channel and keep it going, you will find the link to my Patreon account and my stores on the description of all my videos. Liking, subscribing and commenting on the videos will also help me reach more people, so thank you in advance.